this lesson, we're going to take a look at, again, quadratic relationships, and we're going to start to develop a standard form or a form of a quadratic relationship that's going to be really useful to us to identify key features of parabolas and where the minimum values are, the maximum values are, how far values are, and so on and so forth. So as we're going to go through this, we're going to explore how a quadratic relationship that has the standard graph or the parent graph of y equals x squared changes when we change the values of either the coefficients or we change the value of the constant and so forth. So we will begin by doing a warm-up, and we're going to identify some key points in the parabola that we see here. Okay, and so we want to be able to identify the vertex, the minimum value, optimum value, direction of opening, and so on and so forth. So some of these points are a little easier to determine than others, and I'm not necessarily going to do this all in the same order, but you need to be able to identify what these pieces are. So we want to know what the vertex are, whether it has a minimum or maximum value, what the optimum value is, where the optimum value occurs, the direction of opening, the x-intercepts, and the y-intercept. So first thing that we can do is actually we can determine the direction of opening. Just by looking at this particular parabola, we see that it has an upward facing U, so the direction of opening is quite simply up. So it has an upward direction of opening. And that has a very important impact on us because the direction of opening also tells us whether or not this particular parabola has a maximum value or a minimum value. So because it is opening up, it has a lowest point. Okay, and so this particular parabola actually has a minimum value. Okay, and that minimum value always occurs at the vertex. Okay, and again, the vertex is where the parabola begins to change direction. So the parabola begins to change direction somewhere around here. Okay, it's kind of in the middle of 2 and 3. So what I'm gonna say that the vertex here is approximately positive 2.5 and negative 6. Okay, so the vertex is the position where the parabola actually changes direction, and in this case, it happens at approximately 2.5, negative 6. So the next thing that we can determine is what is the optimum value. Okay, and the optimum value is always the y value of the vertex. And since we know where the vertex is, we can determine what the optimum value is. So the optimum value is given to us right here. Okay, the optimum value is when y is equal to negative 6. So that is in fact our optimum value. We can determine where that optimum value occurs because that optimum value always occurs at the vertex. Okay, and so I'm just going to quickly indicate to you that the vertex is where we actually find the optimum value occurring. The next thing we need to identify is the intercepts, either the x-intercepts or the y-intercept. So we'll start by looking at the x-intercepts first. The x-intercepts happen when the parabola actually crosses over the x-axis, and the x-axis is this line that travels horizontally. Okay, and so we see that this particular parabola actually intersects this x-axis in 2 locations. It occurs right here and also right here. Okay, and so because it happens twice, we need to indicate that the parabola does intersect the x-axis 2 times. So the x-intercepts are actually at -1 and they happen at -1 and again at positive 6. Okay, please do not write down they happen at -1 or positive 6 because they in fact happen in both locations at the same time. So the x-intercepts happen at -1 and positive 6. There is also a y-intercept for this particular parabola, and we can find that y-intercept right here. Okay, the y-intercept happens when the parabola crosses the x-axis, or sorry, the y-axis. The y-intercept happens when the parabola crosses the y-axis. And in this particular instance, the y-intercept happens at -3. Okay, so when the x value is 0, the y value is -3. When the y value is 0, the x value is both -1 and positive 6.